So in this case, we are going to consider some typical questions as we are to work with our steam generation and the nuclear power plants. This is important for you to know the basics as you are to consider the phases of steam generation. So these questions that we are having, they are going to be considered on the phases of the steam generation. So we're just going to need here phases of steam generation. What is it that you are supposed to consider or to work on the steam generation? As you are to consider this part, one, water is considered and the water is being heated as you consider the steam and until the water is boiling. When these stages are the ones that we are considering about. And there are some terms which you need to also know as you are to work with the steam generation. So when you're considering the water, let's say we have got the first stage, it will be water like that. All right. So let's just say we have got the water. This is still the water that we have. So when we have this water, the heat that is affecting or the enthalpy that is going to be considered there is referred to as the sensible heat, which is the liquid enthalpy. So as you consider water, you consider what you refer to as the liquid enthalpy. That is the liquid enthalpy that you consider there, which is the same as the sensible heat. You are considering the sensible heat. So in definition, you might be considered, so what is it actually that you are considering about this sensible heat or the liquid enthalpy? So the sensible heat is simply the amount of heat required, the amount of heat that is required to change the temperature of water as we are considering water. From 0 degrees Celsius to a different liquid temperature. So what I want us to consider is that it was water from 0 degrees Celsius, then it has been changed to another temperature, maybe still 50 degrees or something like that. So as you can see, guys, we still have the water there. So we started with the water. The temperature has just increased to a certain temperature, but it's still water that we have there. It's still the water. The only thing that is differed or the only thing that is going to change here are the enthalpies to say, let's say this is our stage one and this is our stage two. The stage one, the H1 that you're considering is the HF. So HF represents the enthalpy of what? Of what? Which is the liquid enthalpy. You refer to that as HF, which is the one that you just have to take from your steam tables, given a certain temperature. That's the same thing as this two. The enthalpy there, H2, is same as HF. We're still talking about the liquid enthalpy. The liquid is still the liquid that we have. The only thing that has changed is the temperature that you started with and the temperature that you now have at that particular point. You might not start at 0. You might start with a certain temperature. It increases to another temperature, but still under liquid. That is what you need to consider there. Still under a liquid. So as you consider these stages, guys, after the water has been heated, remember the temperature is increasing. We now talk of a where we start to see the steam. So from there, you consider that as the wet steam. All right, so let me just have wet steam. So this was just a normal liquid or water. Then we consider the steam, which is wet steam. From this second phase that we have, the water is now heated up where we can now see the steam. And that will be wet. That is where we consider the latent heat, the enthalpy of evaporation now to be involved. To be involved. So you have to consider that. All right. So meaning to say, if you were to consider this as stage 1, stage 2, meaning to say the stage of wet steam will be our stage 3 in terms of the stages. Remember I said 1, 2. It was water, it's still water. So stage 3, it is now of the wet steam. So H3, which is the enthalpy this time, wet steam, H wet. So that is your H wet for the wet steam. So in this case, we are going to have a formula now. That is HF plus XHFG. So HF, remember, it is the liquid enthalpy or the sensible heat. Then we consider the part of HFG, which is the enthalpy of evaporation, this one. Enthalpy of evaporation, where X is the dryness fraction. So the HF, which is the enthalpy that we have, the liquid enthalpy, and the enthalpy of evaporation, these two, they are to be taken or to be given at a certain temperature. They can be given at a certain temperature that you are having there, or they can be taken from a certain pressure. So it is now issue now that you have to consider to say, what is it that you're given? Is it at a certain pressure? Is it at a certain temperature that you have there? But normally they might give you a pressure there. Temperatures, expect them for water there. They expect to be given temperature. Then you take HF. So the HF, these are value that you have on your steam table. The steam table is having these values. So if you consider these are the values that you have, as you can maybe have got this TS. You are given a temperature. You can have your HF. You can have your HFG. You can also have your HG from there. So even if you are given pressure, you can use the pressure to find these also. So this is simply something that you have to take from your steam table as you are to consider that part. All right. So these are some of the stages that are important. Then the water, this is further heated. Further heated until we have the dry saturated steam. Until we have what we call the dry saturated steam. So the dry saturated steam, which is our Hg, also it's a value which you can simply obtain from your information sheet. You'll be given that one. From your information sheet, you can, from your steam tables, you have that. Then we move on, further heated until we talk of the superheated steam. From wet steam, dry steam, superheated steam. So the part of the superheated steam, let's just have 3 representing our dry. So this is just dry saturated steam. So in case you want Hg, it is just a value that you just take from your steam table at a given pressure. You can obtain that value. Then until the steam is now superheated. So we now talk of the superheat or the enthalpy of superheat. So for the superheated steam, in order for us to determine its enthalpy now, which is the enthalpy of the superheat, which is given as H sup like this, superheated steam. One, this can be obtained from the superheated steam table when we are given the pressure and the temperature which corresponds to that. Okay, I want you to have this so that you can understand each other, because we also have a formula that you can use there. But if you check, if we go down a little bit, all right, let's try. All right, this part here of the superheated, if you check, this one is now written on top, superheated steam. This is for the superheated steam. If you have the temperature for that superheated steam and you have got its superheated temperature, and you also have a pressure that you are given, maybe whatever pressure that you are given, the enthalpy there of the superheat can be determined. Let's say you are under this 50 and your pressure is 10. As you can see here, your H sup can be determined. Same as the volume can be determined. But sometimes you are not given this. So this one is used when the temperature here and the pressure, they correspond to what you're given. Like, is it 200 and maybe your pressure is 50? They do correspond. Then you just take your H sup straight, where you're talking of the 200 there. So this is the value that you are going to use. If it was 250, you have to consider the part of what? 250. If it is the part of 400 degrees Celsius, you have to consider that temperature that you're given of the superheated steam. But like I said, sometimes you are not given that. You are not given values which correspond to what you are supposed to have. How can you determine your H sup, your superheated steam, the enthalpy? So this is given by the formula Hg plus the specific heat capacity of the superheated steam into the temperature difference, which is the change in temperature. So the change in temperature is still the difference between the superheated temperature and the saturation, which is the one that we refer as the saturated temperature. So you'll be given the specific heat capacity of the superheated steam, and also you'll be given this temperature of the superheated temperature in degrees Celsius. You will be given these. Hg, where we talk of the dry saturated steam, and this Ts can be determined at a given pressure. At a given pressure now, we can go and determine these ones at a given pressure. So this is what we have. And also for this Hg, guys, sometimes you might say, what about the formula? What if I want to work with the formula for Hg? Hg, you can use the formula, but there's no need for you to even use the formula because it's a value which is straightforward from your steam tables. Even if you are to use the formula on this Hg, there's no effect, guys. You can use your formula Hg, which is equal to Hf plus Hfg. So maybe you just want to determine your Hg, somehow you're given that. And even for the sensible heat, sometimes maybe you are given the specific heat capacity of water. The specific heat capacity of water is there, and the temperature of water is also there. This H1 that we are talking about, which is your HF, can also be determined from that specific heat capacity of water times the temperature of water, provided that you are given that. You can also use this, but mostly they will give you a certain temperature. Then you find your H1, which is your HF, or H2, which is your HF, a sensible heat. You can determine that direct when given a temperature. So we want to see how these questions are given and how are we going to apply our steam tables. If the superheated is needed, then we will see. The question that we are having, which is our first question, was heat is added to water in order to change. So where is the heat added? The heat is added to water. It's still water that we have, liquid, in order to change the temperature from 49.5 degrees Celsius to 99.6 degrees Celsius. Still as what? As water. So determine the following from the steam tables: the specific enthalpy of water at. Of what? Of water. We are still referring to water here. So as long it is the enthalpy that is affecting water, that's your HF. That's your HF. So we are simply determining H1 and H2, which is our H1 equal to HF at this temperature that we are given at 49.5, which is now from our steam tables. So I want you to get your steam table. If you consider your steam table, you are going to notice under the temperature, because the temperature is the one that you need. So you need a temperature of what? 49.5 as of the temperature. So according to mine here, it's because this one is not in that order of pages, but this is where I have the temperatures here. According to these temperatures on this part of the temperature that we are seeing, down there we can see that we have got the 49.5 here. The 49.5 is there. So with that 49.5 going straight with it, these are the values corresponding from there. TS is 49.5. The volume is there. The HF is there. HFG. What is it that you need? As we need to calculate, as we need the value of what? HF, the enthalpy of water. Remember, this is for evaporation and this is for dry steam. HF is the one for water. So underwater, what is the value that is corresponding there? As it is there, there is no calculation. You just need to take your value. That is what? 207. What about the units? Kilojoules per kilogram. Kilojoules per kg. Those are the units. So our answer was going to be 207 kilojoules per kilogram. All right, so that was a straightforward. You just need your steam tables there. So that's 207. We got 207 kilojoules per kilogram. That is the whole idea. Sorry for that, which is 207. This one, 207 kilojoules per kilogram. We move on to the second one. The specific enthalpy of water at. So it started at this, it was water. So we're going to have our H1 because this will be T1 and this will be T2. So it's now H2, but H2 representing what? Enthalpy of what? The water. We are still working with the water. So that's our HF. As long we are dealing with water, we are dealing with what? HF. What just changed there is the temperature. We are no longer at 49.5 where we used to be. So we are now at another temperature, which is 99.6 That was 99.6. All right. So if you check on this page, you can see 99.6 somewhere there on your temperatures here, 99.6. That is where we have our temperature. And that can, as you can see, it corresponds straight. We need the part of HF here, HF. So the value there is this one, 418 kilojoules per watt per kilogram. So we have got our answer from there. So that is 418 kilojoules per watt per kilogram. Then the last question was to calculate the change in specific end-up. What were you calculating before? Specific end-up. Specific. Now they want you to calculate the change from this one to this one. What was the change? If let's say you're calculating the change in temperature, how do you calculate change in temperature? Final minus initial, T2 minus T1. So it is the same thing even for the change in enthalpy, the final one, which is our H2 minus our H1. So that's the change in enthalpy can be determined. Just like we're calculating any change, final minus initial. So H2, we calculated this. We determined from our steam table, it was there. Minus 207, we also determined this. So that was the change in enthalpy now, which was going to give us 211 kilojoules per watt per kilogram. So you have the change in specific enthalpy. Considering another question, if you take a closer look now, they are saying a boiler. They were given a boiler operating at 1 megapascal. This is the pressure of the boiler, 1 megapascal. But if you check properly, you are going to notice as you are to work with the pressure from your steam table, you are now forced to have kilopascals so that you can see what is corresponding to that particular pressure. You cannot see if you are having megapascals like that. It must be from the kilopascal. So that is going to force us to convert the given pressure to be in kilopascals, as we can see from our information, from our steam tables. So 1 mega to kilopascal. Remember, mega is simply like this, million. So kilo, we just need to remove these three to represent kilo. So you're left with what? 1,000. So that's 1,000 kilopascal. 1,000 kilopascal. The boiler pressure is given with a dryness fraction of, and also the dryness fraction is given of 0.8. To a steam engine is operating this way, and it has to deliver steam with the dryness fraction. It delivers to the steam engine. So the question was to calculate the specific enthalpy of what? Wet steam. As we considered from those formulas, we saw that the enthalpy of wet steam can be determined. Let's just hope I did not remove that. If you consider the H wet for wet steam, that's our H3. Remember, you've got stages 1, 2, 3, 4. So that's your H wet. So if you want to write as H3, it's up to you guys, but that's your H wet. And from our formula, we saw that H wet can be determined. What is our formula? So this one is straightforward. So remember, our H wet is equal to, that's HF plus X HFG. Where I said these two are to be taken at a certain temperature, at a certain pressure. At a certain pressure, you'll be given that. At a certain pressure. That's why we are supposed to have that pressure. So with the pressure of 100 kilopascal, what is HF for the enthalpy of water and that of the evaporation? So let's go to our steam table under 100 kilopascal. So if we consider our steam table, you're going to notice this is our 100. As you could, this is, remember, pressure here, pressure. So where is it that it's 1,000, not 100? Where am I having the 100, guys? This is 1,000. All right, 1,000, 1,000, 1,000, guys. Remember that. So I need that 1,000 here. All right, this is where we have the pressure in kilopascal. Remember, this is your pressure kilopascal. And thus we've got our 1,000 there. So meaning to say, we were going to obtain straight. All right, let me just do this, guys, so that I don't have an effect. I'm just going to take it straight like this. I hope you're going to see it. So this is where we have our values. So under these values, we need where HF is, because we saw that there is HF on our formula and there's also HFG. So going straight here, your HF, we can see that is 763. Our HFG going straight, we can see that is our 2014. So we are going to substitute these values that we are obtaining from there. Just like that. Everything is there, guys. So as long as you understand your steam tables, this is not going to be a problem. So what is your HF? We saw that our HF was 763. Then what about HFG? 2014. X is given the dryness fraction. So remember your X is dryness fraction, 0.8 times 2014. You just take the values that we saw from that one. So that is our H wet, enthalpy of what? Wet steam. So that was going to give us 2,374.2 kilojoules per what? Per kilogram. The units there are also important. Per kilogram. The number two, the heat supplied by the boiler for 5 kilograms of steam. Remember, this is enthalpy, guys. We are talking about heat. This is kilojoules is what? This is heat, guys. Kilojoules. We're talking of heat. But it's heat per each per kilogram. 1 kilogram. 1 kilogram. This is the heat that we need. So what about if we have got 5 kilograms? What is the amount of heat that we are going to need? That is the question. So the amount of heat that we are simply going to have, which can be written as Q, is simply now the mass times the enthalpy that you are given. So in this case, we're talking of what? H wet. So if it is Q wet, then it is going to be mass times H wet. It depends with what you're given. What is the mass? 5 kilograms. Remember, this is per each. So it will be like this: kilojoules over kilogram times kilograms, like this. This cancels. You remain with the kilojoules. That is why we have to multiply it by the mass. So just like that, guys. The moment you multiply this, you are going to have the heat now, which is in what? In kilojoules. So that was going to give us 11,871 kilojoules. So you can even write this as Q wet. Then here you write Q wet or H wet. It's up to you. This is the heat. So even on each case, even if you're given the mass here, they can ask you to calculate that heat. Mass times the specific heat capacity that you're given there. I mean, the specific enthalpy that you're given there. You have the heat supplied in kilojoules. All right, let's consider another question. A boiler operating at 1.5 megapascal. We are back to that pressure. If the pressure is given as 1.5, it means 1 1,500,000 like this. So remove these three zeros. What do you remain with? 1,500. 1,500. So the easier way, just multiply whatever that you're given times 10 to the exponent of 3. So meaning to say this will be 1,500 kilopascal. Remember I said pressure is given in what? Kilopascal. So they're saying this boiler with this pressure, it delivers steam at this rate. This is the mass of steam, but it is given in kilograms. Take note there, 15 kilograms per second. It's not usual. The usual one that we are used just like kilojoules, kilograms per second. So this has to affect our answers, this part. And a temperature of to the turbine, which is, we are talking of what? The superheated steam. The temperature that is affecting of the superheated to the turbine. It is 250 degrees Celsius. The specific heat capacity for the what? For the superheated steam we are given. The specific, the moment that they give you the specific heat capacity like this, forget about that formula that forget about using your superheated steam to determine the specific enthalpy of the superheated. Remember I said you can use pressure and what? And temperature. At the moment that they give you this specific heat capacity, it means this does not work. If you check on your superheated steam, you will not find, okay, let's go back to our superheated steam like this so that you understand me very well. We're just gonna go back to our superheated steam. Under the superheated steam, remember this was our information, it was like this. This is what we have. Under the superheated steam table, remember they show you the temperature. I want you to see this information. They show you the superheated steam and also the pressure. So what I'm saying is that you will not find, as we are given there, remember our pressure is 1,500 and our temperature is 250. We have got 250 here, but let's check. Are we going to have 1,500? If we check, all right. If we check this one, 1,500 versus 250. All right. Let's check. So this one is there. All right. This one is there, guys. 250 ways or 250. No, 250. Yeah, it was 250. We need to go with that one straight. Let's hope I'm not going to miss my values, guys. Yeah. Let's hope I'm not going to miss my values. I want us to go straight with those values. All right. If we check here, this is 250 here. All right. 250 is there. Then the 1,500 is there. So if we take straight, it is going to be this value. All right. This one, you could have used that one because it's there, this one. So when you are given now the specific heat capacity like that one, guys, this one you can just take it, you see, 2925 is there. The pressure corresponds, the temperature corresponds. Remember, this was 250 here, according to this, but this is where we have 250 down there. So this one, you could have also used this part because it's there. Okay, so that is, we got this one, 2925. Okay, so that was our H soup there. 2925. All right, just like that. 2925 as it is, which is kilojoules per what? Per kilogram. All right, but let's say we did not see that. Okay, because you saw that the pressure is there, the temperature, these two, they give us that enthalpy, the specific enthalpy of the superheated. But if we are given the specific heat capacity of the superheated steam. Can we also consider it and see? All right. So let's consider that into our calculation. Our H sup was going to be, remember our formula? That's Hg plus specific heat capacity of the superheated, T is superheated, minus that of the saturated steam, where Hg and this Ts are given from the pressure, these two from the given pressure, 1,500. This is given and this is also given, remember. So let's substitute our values and see. So according to this now, if you are using this formula, Hg and Ts, you are not going to use the superheated steam table. Remember, we had this part of this one. This one is what we call the superheated steam table, guys. This one that shows you the part of the superheated steam, as you can see here on top of the superheated. You are not going to use this when you are using this formula. When you use this formula, you're supposed to go back to your normal steam table. This is our normal steam table, which gives us those values of pressure, these and that, this one. That is where you refer back there. But at what? At 1,500. You're supposed to refer that at 1,500. All right, so let's check where are we having 1,500. Let's just hope we've got it on top here. All right, no problem. So the problem with mine, guys, is just mixed. These pages were being mixed. I don't know how did they just do this one. All right, but if you check, this is where we have 1,500 under. Remember, like I said, we go back to the normal steam table and we are going to need the value there on our steam table. Remember, we're going to need Hg and this Ts, the saturated, these two, the Ts and the Hg. All right, so 1,500. This is where I see my 1,500 here. All right, let me try and indicate it. 1,500. So if you're going to take it properly, guys, on your information sheet, you're going to see that this is the part of your TS. So the temperature is what? 198.3. And the part of Hg, this was going to be the part of Hg at the end, which was 2790H. This was our Hg here. It's because of the page I cannot show the full page, but you can see it from your steam table. That is where your Hg was going to be. So you can use that. But when you are using this, you must refer back to what? The normal steam table, not the superheated one. The superheated one gave us an answer direct. We already have the answer here. We just want to prove if this is true, if it tallies. Okay? So what is our Hg? Remember, we got 2,970 plus the specific heat capacity of the superheated, that one you are given, 2,611 into T sup, which is the superheated, 250, minus the saturation. This one, we saw it from our steam table. It was 198.3 from those values that I marked. That was 198, that was 198.3. Remember, from these values, talked of the 198.3 and also the 2790 at the end. So that is how you can simply have these values. So with this, guys, your H sup was going to be calculated, superheated, the end up of the superheated steam. And this was going to give us 2,924,989 kilojoules per kilogram. As you can see, guys, these values are approximately the same. By just rounding off, this becomes a 5 there. Yes, because we are using a rounded off figure. In actual sense, if you're using the exact value there, we were actually going to obtain exactly the same answer of 2,925. So you could have used any value there. There was no need for any of this calculation. You have got your enthalpy, the specific enthalpy of the superheated steam. Number 2, the rate of heat supplied by the boiler. They are very, very clever in asking you these questions. The the rate. The moment you talk of this rate, there must be per given time, per second. So if we talk of the heat, meaning to say we are talking about Q per second, heat per second. That is the rate. Just like what you're given the mass here. Remember when they gave you the mass, they said what? It delivers steam at a rate. The moment they talk of the rate of 15 kilograms per second. Per second. So it is now different from the question where you calculated heat on this one. It was just the heat for that 5 kilograms. It was just a basic, the normal heat that you are used to. But now we need the rate. So you must use the mass in kilograms per second for you to obtain what? Kilojoules per second also. So that was very, very important there. So our Q was simply going to be the mass per second because we need Q per second, this one. So it was going to be mass per second times the specific, which is the enthalpy of what? Of superheat. So what is it that we have? The mass per second we are given for which mass? 15 kilograms per second. Multiply it to this, 2924,989. You are going to obtain 43,874,835, which is in kilojoules per second. The rate of this per given time. If they specify per minute, you have to convert to per minute. But there, it was just calculate the rate. So you just use the mass that you're given. The mass was per second. So let us just leave our answer as what? Kilojoules per second as well. So we shall have continuous revisions until we are done with our topic, and also referring question papers. How are you supposed to be attempting your questions in answering of the this part of our STEAM generation and the nuclear power plants? So for you not to miss any of the classes, make sure that you're part of the membership, because as a membership, we shall be having more revisions considering our power machines N5 and any other N5 revisions that we have in our syllabus. Till we meet again.